Number 12. Two sides and an angle are given. Determine whether the given information results in one triangle, two triangles, or no triangles at all. Solve any triangle or triangles that result. So here we're given side A and side B and angle B. Now me personally, I prefer to kind of draw things out so I can see what's going on. So I'm going to go ahead and do that here. So now we can see that we have an angle and a side across from it, and then another side floating around. So what I can do is use my law of sines to solve for angle A, which will be really nice. Because the sine of angle B, which is 15 degrees, divided by side B, 7, should be equal to the sine of angle A divided by side A. And then all we have to do is solve for the variable that we still have inside of our equation, which is angle A. So I'm going to go ahead and multiply both sides by 9, and we get the sine of angle A equals to 9 times the sine of 15 degrees divided by 7. And then to solve for angle A, we're just going to take the sine inverse of both sides. So angle A equals to the sine inverse of 9 times the sine of 15 degrees divided by 7. And we'll just plug this in our calculator. So I got angle A equal to 19.4 degrees. Well, when we use law of sines to find an angle, we have to check for a second triangle. So what we're going to do for our check, our second possible value for angle A, which I'm going to call A sub 2, will be equal to 180 degrees minus what we originally got for angle A, which was 19.4 degrees. So my second possible value for my angle A is going to be 160.6 degrees. Then to see whether or not this will result in a second triangle, I'm going to take 180 degrees, subtract the original angle I was given, which was 15 degrees, and then subtract the angle that I just found. So my A sub 2, 160.6 degrees. And that's going to give me 4.4 degrees. So since whenever I subtracted these two angles from 180 degrees, I got a positive angle, we have two triangles. If I were to have subtracted my original angle of 15 degrees and A sub 2 and gotten a negative angle, then we would only have a single triangle. So now I need to solve both of these. One triangle with A sub 1, or our original A, angle A, and one with angle A sub 2. So I'm going to go over here, and what I'm going to go ahead and do is split up the rest of the space that I have to work in half. One side will be angle A sub 1, one side will be angle A sub 2. So our angle A sub 1 was that 19.4 degrees. And our angle A sub 2 is going to be our 160.6 degrees. And then I want to solve the rest of my triangle using these separate angles. So now that I have angle B, and I'm going to start with angle A sub 1, I can find angle C sub 1. So our subs, or the subscripts, of my angles and sides from this point on will have a 1 if it's for A sub 1, or a 2 if it's for A sub 2. Because we're going to get a set for each of those angles A. My angle C sub 1 will be 180 degrees, minus 15 degrees, minus 19.4 degrees. So I get my angle C sub 1 equal to 145.6 degrees. So far I have angle A, angle B, side B, and now angle C. So all I have to do is solve for side C. So I'm going to have to use my law of sines, because if we start with one law, we want to continue to use that law throughout the rest of the problem, or else we might run into errors. So I'm going to have the sine of 145.6 degrees over side C, sub 1. That'll be equal to, and then I want to use any of my original information that I can to find this, because this will give me the most accurate answer possible. So I'm going to use the sine of 15 degrees over 7. And then we can solve for side C sub 1. So I'm going to go ahead and cross multiply. And then divide both sides by 15 degrees. So I get side C sub 1 equals to 7 times the sine of 145.6 degrees divided by the sine of 15 degrees. And we can just plug that in our calculator. And that gives me 15.28 for my side C. So then all we have to do is these two steps find angle C and side C, but for A sub 2. So my C sub 2 is equal to 180 degrees minus 15 degrees minus A sub 2, 160.6 degrees, which will give me my C sub 2 equal to 4.4 degrees. That should look really familiar. That's actually our test for our second triangle. So for our second triangle, we're trying to see if we can actually get a positive C sub 2, or whatever our third angle is. If it's positive, then it's a real thing. But we can't have negative angles. So if we get a negative number, what's not a triangle, what's possible? So then we're going to go ahead and solve for side C sub 2. And we're actually going to use the same proportion we had from before. So I'm going to have this sine of the angle I just calculated over, and this time it'll be side C sub 2 equal to the sine of 15 degrees over 7. And we can cross multiply again. And then divide both sides by the sine of 15. So my side C sub 2 should be equal to 7 times the sine of 4.4 degrees divided by the sine of 15 degrees. And we can plug that in our calculator and get C sub 2 equal to 2.07. Now, me personally, I round my angles to 1 decimal place and my sides to 2 decimal places. Be sure to look to see if your instructor specifies the number of decimal places on the final exam you have to round to, because it may be different than mine.